In the previous video, I looked at adding, subtracting, and multiplying complex numbers. Now I want to look at dividing complex numbers. And in order to divide complex numbers, I need to talk about the complex conjugate. If I have a complex number, a plus bi, its complex conjugate is going to be a minus bi. We just changed the sign on the part that has the I, the imaginary part. And this is very nice because if I try to multiply a plus bi times a minus bi, if I try to multiply conjugates, I would have a squared minus abi plus abi minus bi squared. I can see that these middle two terms cancel each other out since I have a negative abi plus abi. And I squared is -1, so I would have negative b times -1 or positive b squared. So I get rid of that complex part and I end up with just a squared plus b squared. And in order to divide, I'm going to use this complex conjugate. I'm going to divide by multiplying by 1 using the conjugate of the denominator. So let's look at some examples. Let's look at 9i over 5 plus 6i. The conjugate of the denominator is 5 minus 6i. We changed the sign on the imaginary part. So I'm going to multiply by 5 minus 6i over 5 minus 6i. 9i times 5 is 45i. And 9i times minus 6i would be negative 54i squared. The denominator, since these are complex conjugates, I end up with a squared plus b squared. So I have 5 squared plus 6 squared. Simplifying this, I squared is -1, so that means I have a positive 54 plus 45i on the numerator. And on the denominator, I have 61. So I can rewrite this as 54 over 61 plus 45 over 61 times I. So I have it in the appropriate a plus bi form. Now let's look at I over -3 minus 4i. The conjugate of the denominator changes the sign of the imaginary part, so we have -3 plus 4i. And then we do the same thing on the top since we want to multiply by 1. For the top, I have I times -3, that's minus 3i. And I have I times 4i, or 4i squared. Since the denominators are conjugates, I have -3 squared, which is 9, plus 4 squared, which is 16. I squared is -1, so the top is -4 minus 3i. And on the bottom, 9 plus 16 is 25. So I could rewrite this as -4 over 25 minus 3 over 25i, so that it is in the a plus bi form. Let's look at one slightly more complicated. -4 minus 7i over 1 minus 3i. So we always move to the denominator and take its conjugate. The conjugate of 1 minus 3i would be 1 plus 3i. And then we multiply both the numerator and denominator by this. In this case, I would need to distribute, so I have -4 times 1, that's -4. -4 times 3i, that's -12i. minus 7i times 1 is negative 7i. And negative 7i times 3i would be negative 21i squared. On the denominator, since they're conjugates, I have 1 squared plus 3 squared. In other words, 1 plus 9. On the top, this is negative 4. Minus 12i minus 7i is negative 19i. And then I squared is negative 1, so this is plus 21. All over 10. Simplifying, negative 4 plus 21 is 17, minus 19i, over 10. In other words, this is 17 over 10 minus 19 over 10i. Equivalently, 1 plus 7 minus 1.9i. For my last example, let's do 6 minus 3i times 7 plus 8i. The conjugate of the denominator would be 7 minus 8i, since I just need to change the sign on the piece containing the I. 6 times 7 is 42. 6 times negative 8 is negative 48i. Negative 3i times 7 is minus 21i. And then negative 3i times negative 8i would be positive 24i squared. On the denominator, since they're conjugates, we have 7 squared plus 8 squared, or 49 plus 64. Simplifying, negative 48i minus 21i is going to be negative 69i. I squared is negative 1, so this is minus 24. And on the bottom, I have a 113. 42 minus 24 is 18, so I have 18 minus 69i over 113. Or 18 over 113 minus 69 over 113 times I.